Three-dimensional structures can be generated by placing two-dimensional layers one above the other. Place the first layer of two-dimensional hexagonal close-packed layer A-type, then place second layer over the first layer such that the second layer fits in the depression of the first layer. Since the spheres of the two layers are aligned differently, second layer can be named as B-type. Some of the triangular voids of the first layer are covered and some of the voids are not covered. This gives rise to different arrangements. When the triangular void of the first layer are covered by spheres of second layer or vice versa, it gives rise to a tetrahedral void because when the centers of the four nearing spheres are joined, a tetrahedron is formed. When the triangular voids of the second layer are placed on the triangular voids of the first layer, their shapes do not overlap. The apex of one triangular void points upward and the apex of the other points downward. Such voids are surrounded by 6 spheres. This gives rise to an octahedral void because when the centers of the nearing 8 spheres are joined, an octahedron is formed. The number of these two types of voids depends upon the number of close-packed spheres. If the number of closed-packed spheres is equal to n, the number of octahedral voids generated is equal to n. The number of tetrahedral voids generated is equal to 2n.